Dear students, today we are going to start elasticity concept. So this concept was given by Alfred Marshall. Actually, elasticity is related with the flexibility. In ordinary sense, if we talk about elasticity, it means if we are talking about flexibility. Now the question is how flexibility can be applied in the area of economics. When we talk about elasticity of demand, it means we are talking about, you can say, the flexibility of demand, or you can say the change sensitivity of demand, right? So according to Marshall, the elasticity concept provides the information as to how much or to what extent the quantity demanded of a good will change as a result of a change in price, right? So on the basis of this responsiveness of the change in price, the elasticity of demand can be classified into different parts. The most important are price elasticity of demand, income elasticity of demand, and cross elasticity of demand. So what is the basic difference between these three concepts? All these three concepts are focusing on the change in demand, but the factors are going to be different. For example, in case of price elasticity, we will focus on if the price is going to change, then, or you can say, if price is going to change, what will be the impact on demand? Income means if income of the consumer is going to change, if income of the consumer is going to change in percentage, right? So similarly, percentage change in price, percentage change in income. So what percentage change will be there in demand? And cross elasticity concept is related with the demand and price relationship of two goods. So one by one, let's move further to understand these concepts in detail. First, consider price elasticity of demand. This is denoted by ED, T for demand, or EPP for price. So according to this formula, price elasticity of demand is the proportionate change in quantity demanded of a good divided by proportionate change in price of good. X proportionate means percentage change. Whenever we use this delta sign is used for change in economics, right? Means this delta sign represents the change. Change can be positive, can be negative. So algebraically, this formula can be represented as, or you can say symbolically, this can be represented as delta Q upon Q divided by delta P upon P. So delta Q upon Q is the percentage change in quantity demanded. The formula for percentage change is delta Q upon Q multiplied by 100. Similarly, percentage formula in case of price will be delta P upon P multiplied by 100. So 100 is common in numerator and denominator, so the value will be cancelled, and finally we will have the formula equal to delta Q after rearranging into price divided by delta P into quantity demanded, right? So these are the meaning of these symbols which have been used in this formula. Delta Q represents change in quantity demanded, Q represents original quantity demanded, delta P represents change in price, and P represents original price. Okay. Now, let's focus on degrees of price elasticity of demand. So, on the basis of to what extent demand can be changed with respect to percentage change in price, it has been categorized into 5, right? For example, small e has been represented for price elasticity of demand. This is the symbol used. Generally, we write as ED and EP, right? So, for perfectly elastic, I will later on explain what is the meaning of perfectly elastic. So the maximum limit is infinity. Value price elasticity can be infinity, and the minimum value can be 0. That will be perfectly inelastic. Inelastic means no change, right? Perfectly elastic means infinitesimal times change in price, right? And the mid value of 0 and infinity has been taken as 1, which is known as unitary elastic, because in mathematics we use unit word for one value. Okay, right? So within the range of 1 and infinity, there is a range, this particular range from 1 to infinity. This is known as relatively more elastic, because value of elasticity becomes more than 1. And the range between 1 and 0 known as relatively more inelastic, because the value of elasticity is less than 1, right? Okay, so there are the different methods of measuring price elasticity of demand. Number one, percentage method. Percentage method is the actual formula that we have understood. This is percentage method because we are talking about percentage change in quantity demanded in response to its price, right? And second method, total expenditure method or outlay method. Third one, point or geometric method. Fourth, arc elasticity method, and the last one is revenue method. So let's go for study these methods one by one. So first method is percentage method, or you can say the method through which we can calculate price elasticity of demand. So diagrammatically it has been represented. We have a demand curve, right, and we have shown on vertical axis price has been taken. We are going to show the change in price, and on horizontal axis quantity demanded has been taken, and we are going to show the change in quantity demanded. As you can easily recognize that a light blue part, sky blue color part that is highlighted here, it is represented the change in price multiplied by the quantity demanded. Means we have calculated here the area of this rectangle. The area of rectangle is equal to length into breadth, so we need to find out what is the length and what is the breadth of this rectangular area. So the breadth is delta p, means change in price, and the length is equal to original quantity demanded, okay, at initial point, right? So when we multiply this, then we have the then we find out the area of this blue colored rectangular portion. Similarly, when we are talking about this pink color vertical portion, then we can find out again the area. So breadth is equal to change in quantity, right, and the length of this area is equal to actual is equal to the price, actual price, right? So when change in quantity multiplied by price, then we can have the area of this particular vertical portion, right? When we divide these two segments, this pink portion actually represents this pink portion actually represents numerator of the formula, and this blue color portion represents denominator. So when we divide numerator by denominator, then we have the price elasticity formula according to this diagram, right? Next method is known as total expenditure method. So we have taken three variables simultaneously here. Number one, in first column we have taken price change. Two types of changes can be there, either price falls or price rises. And three elasticity values we have taken, where price elasticity greater than 1, price elasticity less than 1, and price elasticity equals to 1. So with response to change in price and particular value of elasticity, we have to focus on what will be the change in total expenditure, okay? So when elasticity is greater than 1, what is the meaning of elasticity greater than 1? Elasticity means whatever, if the elasticity value is higher, right, then the possibility of shifting of the customer from one product to another will be higher, right? What is the meaning of higher elasticity? If there is a change in price, maybe fall, maybe rise, then the scope for the consumers or the customer to shift from one product to another will be higher. Now keep this point in your mind and then focus on it. If the price of a particular commodity is falling, it means the commodity is going to be cheaper, right? So what will happen? You will purchase more and more this cheaper commodity, right? And when you will purchase more and more, then your expenses will increase, right? So total expenditure will increase when price falls and elasticity value is greater than 1, right? Okay, when elasticity value is less than 1, right, less than 1 means lesser scope for the customer to shift from one product to another. Suppose now a company falls the price of the product, what will happen? Then the other customers from the market will not if the price of the product is falling and elasticity is less than 1, it means whatever, if the price is going to be fall, even then the customer will not increase the demand, so comparatively your total expenditure will be lower. And if elasticity is equals to 1, it means if the price is going to fall or rise, then accordingly your total expenditure will be the same. So this relationship has been shown with the help of three figures. In the first figure, elasticity greater than 1, and we have shown highly elastic demand curve, which has been represented by a red line. right? So this is showing that, as I have told you, that this particular portion is rectangular portion is numerator, and this horizontal rectangular portion is denominator. So when we divide numerator and denominator, because numerator is greater, that's why the value of elasticity will be greater. And in this case we have to compare between these rectangular portion. Number one, initially the consumer is operating at the price 5.05, right? And at this price he is purchasing 90 units. So we have a vertical rectangular portion, this one, right? Now the price falls, price becomes from 5.05 to 5, and due to this falling price, what happens, the customer is now purchases more, not customer, the consumer now purchases more units from 90 to 100. So now the rectangular portion shifts from vertical to this horizontal position. Now we have to compare these two rectangular portion. One is vertical and another is this horizontal. So this particular portion is the common in both of them. So what is the remaining part? Remaining part is this particular portion and this horizontal minor portion. So we have to divide them, then we will find that now elasticity is greater than 1. So it has been proved that if the price falls and elasticity is greater than 1, then total expenses will increase, because initially the horizontal rectangular portion was very much less, and later on, after falling price, this was increased, right? So it is indicating that your expenses have been increased than before. Similarly, in case of elasticity less than 1, steeper demand curve we have taken. Again same price 5.50. This particular portion we are purchasing 99 units. Now price reduces from 5.5 to 5, and we are purchasing more units from 99 to 100. Now we have to compare these rectangular portions. So this portion is common in both the cases. Now we need to compare this horizontal vertical portion, this horizontal rectangular portion and this vertical rectangular portion. So in this case numerator is smaller and denominator is wider. So when we divide, value of elasticity is in this case, just a minute, yes, value of elasticity is in this case because numerator value is lower, so this is less than 1. So what is going to be happen? Initially expenses were more, and now the expenses are decreasing, because we need to compare these rectangular portions after change. So initially rectangular portion was greater, and later on this is narrower. Similarly, in case of elasticity, this is the case of elasticity equals to 1, this is not less than 1. So this is equals to 1, right? So we have to use the sign equals to, okay, right? This is applicable for equals to 1. So in this case, when we compare, this rectangular portion is common. This square box is common in both the area, before price and after the price, right? Before price and before change and after change, and we have to compare these portions, right? And almost, because there is slightly difference, but these two are equal, you can say. So in this case total expenditure, because numerator and denominator both are the same, so there will be no change in total expenditure. So these are the three cases that we explained with the help of the diagrammatic representation, right? Okay. Third method is point price elasticity of demand. So for point price elasticity, we have to apply a particular formula that is known as lower segment upon upper segment. So suppose we have a downward sloping straight demand curve, then different points we have labeled here. For example, point P, and this is the middle point of this demand curve, and last point is at unit number 16, right? Okay, suppose we are operating at midpoint, where unit elastic we have calculated. So when if it is a midpoint, so lower segment and upper segment of demand curve both will be equal, so elasticity will be equal to 1. If you are operating at point P, the lower segment exists here, but there is no upper segment. So lower segment, for example, it is 1 and upper segment is 0. So 1 will be divided by 0, value will be 0. one will be lower segment, yes, 1 will be divided by 0, so value will be infinity. Okay, and similarly at this point there is no lower segment, it means numerator will be 0, denominator will be 1, so value will be 0. Similarly at different points we can calculate the value of elasticity of demand, right? So this experience or this example has been represented in this form. Multiple points we have taken, A, N, L, M and B, and at these respective points we have calculated the value of price elasticity of demand with the same formula we have applied, right? Now this is point price elasticity in case of non-linear demand curve. So this is non-linear demand curve. What we have to do here, we need to draw a tangent. When you draw a tangent, then you can label the points. The midpoint elasticity will be 1, at this point elasticity will be infinity, at this point elasticity will be lower than 1. It means on a non-linear demand curve, at a particular point, first of all you need to draw a tangent, then you have to find out at that particular point whether both line segments are equal or not equal. So accordingly you have to apply, and you can find out the values as represented in previous slide like this. Okay, fourth method is arc elasticity of demand. So we have to measure the value of elasticity over an arc. In this case demand curve is non-linear, right? Initially we are at point P1, and at point initially we are at point K, and with respect to this, at price OP1 we are demanding OQ1 quantity, right? Suppose the price of this commodity falls, becomes P1 to P2, and now because now the commodity is cheaper, so we can purchase more, we can demand more, so Q1 becomes Q2, and another point we have, that is point L, right? So to find out arc elasticity of demand, the original formula of point elasticity we use, that is delta Q multiplied by P. If you remember, this is the formula, delta Q multiplied by P divided by delta P multiplied by Q. Okay, so I am talking about this formula. So let's go back. Yes, I am talking about this. So we applied this particular formula, but in that case there was only one price, but here we are labeling two price levels, so we have to take the average of P1 and P2. So P will be replaced by P1 plus P2 divided by 2, and Q will be replaced by Q1 plus Q2 divided by 2. Because 2 is common in both the fractions, so 2 will be cancelled, and finally the formula will be reduced to delta Q under bracket P1 plus P2 divided by delta P under bracket Q1 plus Q2. So this is the method of calculating arc elasticity of demand. Last method is revenue method. For this revenue method, price elasticity of demand equal to AR. What is AR? AR is average revenue divided by AR minus MR, and MR is marginal revenue. Actually, this is the revenue concept that we will study in market structure, right? So in that for your common understanding, so I just want to tell you, average revenue in ordinary sense is actually price, right? Marginal revenue means the change in total revenue with respect to per unit change in quantity sold. Okay, so this formula when we apply, suppose this is in the lower panel we have drawn revenue has been taken on vertical axis, and this is price elasticity of demand. Decrease in price elasticity of demand has been shown with respect to revenue. This is actually total revenue curve, which is inverted U shaped. When it is maximum corresponding to this point, in the above panel we have taken demand curve, means average revenue curve, right? Because price is denoted by demand curve, so demand curve also known as AR curve. So on this curve, when TR is maximum, so at the midpoint AR is at the midpoint according to point elasticity formula, elasticity value is equal to 1, right? So if you know the values of AR and MR, if you know, then you can easily calculate price elasticity of demand through this method. Okay. So what is MR? MR is basically one more. Let me insert here. For example, I am inserting one line here to make you understand. Suppose this line I have drawn like this. Mm, yes, this is the line. Okay. So this is actually a marker. So this is the position of a marker, and a marker actually lies in the half portion of AR. So when MR is 0, this is MR at the bottom line. MR becomes 0 because it is going to touch x-axis. When MR is 0, then total revenue is maximum. So when you write here MR is 0 and AR is the elasticity of AR, so at this point the value will be equal to 1, right? So numeric values of AR MR you can substitute in this formula. This panel is actually representing relationship between AR MR and TR. Okay, so later on in market sector we will go into the depth of this diagram, but for elementary idea you can have this formula. If you have different values of AR and MR, then you can directly substitute in this formula and you can find out the answer. Okay. Next is determinants of price elasticity of demand. These are the factors at which value of elasticity depends. Number one, availability of close substitutes. So if too many substitutes are available in the market, what will happen? There will be higher scope for the customer to switch from one product to another if the price is going to increase or if price is going to significantly change. So sensitivity will be more and more if more substitutes are available in the market. So elasticity will be higher. Importance of commodity in consumers budget. Suppose for example in your budget necessity items are most important. So without necessity we cannot meet out our daily requirements. So in case of necessities, whatever be the price, you cannot reduce the consumption of those items. For example, spices, salt, and other items like flour. Okay, so these items are necessary items. So in this case, whatever be the price, your demand will not go to change significantly. So in this case, elasticity will be lesser. Number of uses of a commodity, for example, milk. So milk is utilized for a number of uses. So if the price of milk is going high, very high, then what will you do? Then you can use the milk for some significant for some particular purposes. For example, if there is a patient in your home, if newborn baby is there in your home, then you will restrict the consumption of it from other alternative uses and you will use milk only for the most urgent requirements of the family. So in this case, whatever if the price is going to up, then you will reduce your consumption. So elasticity will affect your demand. Complementarity between goods. If two goods are complementary items, because these are joint commodities, or you can say are used in the fixed ratio, so if the price of one commodity is increasing, then the demand for another will decrease. We will come to understand this concept clearly in case of cross elasticity of demand. Okay, and the time for adjustment, short run and long run. In the short run, very much less time we have for making adjustments in our demand requirements. So in this case, if price is going to change, then no much change in our consumption habits. But if long run is there, then in the long run we have sufficient time to make changes in our demand pattern. So in that case, if price is going to change in the market, then we can explore the market and we can make changes in our demand accordingly. So elasticity affects our demand. Now next is cross elasticity of demand. This is applicable in case of two goods X and Y. Suppose you have two goods X and Y. So what we are doing according to this formula, in numerator we are taking proportionate change in quantity demanded of good X, and in denominator we are taking proportionate change in price of good Y. It means we have to focus on if the price of good Y is going to change, then what will be the impact of this change in price on the demand of another good, that is X. Okay, so algebraically this can be represented as proportionate change, percentage change we are talking about. So this will be delta Qx upon Qx divided by delta Py upon Py. similar to price elasticity formula, but only we have taken two goods X and Y. So price is taken in case of Y good and quantity is taken in case of X good. So after rearranging, we have the formula EC is the symbol for cross elasticity, that is equal to delta Qx multiplied by Py divided by delta Py multiplied by Qx. And their meaning is delta Qx represents change in quantity demanded of good X, Qx original quantity demanded of good X, delta Py change in price of good Y, and Py is original price of good Y. Diagrammatically, we can show that cross elasticity of demand in case of substitute goods. Always keep in your mind that cross elasticity is always positive in case of substitute goods. Why we are calling it as positive? Because in this case the demand curve becomes upward sloping. Why it is upward sloping? For example, we are taking here two commodities. One is coffee and another is tea. Right, T is taken on vertical axis, right, but not going to be appeared here, no problem. Okay, T is here. So suppose this is the initial situation, this is initial situation Q1 and initial price is, for example, P1, this point P1. So when the price is P1 and quantity is Q1, the customer is purchasing Q1 unit of coffee, right, and this is the price of tea. On vertical axis we are taking price of tea, and on horizontal axis we are taking quantity of coffee. So for numerator we are using coffee, for denominator we are using tea. So suppose the tea is going to be dearer, so we are moving from this price level to higher price level. So what will happen if tea is going to be costly as compared to tea is going to be costly as compared to coffee? So many of the customers from the market will substitute their consumption, and they will replace coffee in place of tea, because coffee is cheaper as compared to tea, and now tea has been become dearer than before. So we will move in upward direction. So the change in both the variables is positive, price is increasing as well as demand is also increasing. That's why in this case demand curve is upward sloping. So this is the case of substitute goods. Similarly, the case of complementary goods, negative elasticity is there. We have taken two items, petrol and car, because if one is not available then another cannot run. So these are complementary goods dependent on each other, right? Initially we have the price P1 of car, and at this point we are using petrol quantity Q1. Suppose now the car becomes dearer, the price of car increases from P1 and P2. So what is going to be happen? Now the petrol demand is going to be reduced from Q1 to Q2. So what you are observing here, that there is inverse relationship or negative relationship. If the price of one commodity is going up, then simultaneously demand of another commodity is going down, because these are correlated. If you are purchasing lesser quantity of car, then but obviously then your consumption of petrol will also be lower down. So this is the case of complementary goods, and in this case demand curve is downward sloping, right? So this is the relationship of price consumption curve, EP and EC. So I'll later on explain in detail what is price consumption curve. So this relationship has been represented here. PCC, if it is upward sloping, downward sloping and straight line, then what will be the value of price elasticity and cross elasticity. So you can better understand this concept when we will focus on price consumption curve. Okay, so in my successive lectures I will cover this topic. Importance of cross elasticity of demand in economic theory. In case of substitute goods it is positive, in case of complementary goods it is negative, as we have already discussed. Easy in distinguishing various market forms. This classification was given by Professor Triffin. In case of perfect competitive market structure, value is infinite. In case of natural monopoly, it is very low. In case of pure or absolute monopoly, it is zero, completely zero. And in case of monopolistic competition, it is very large, or you can say positive. So how these values are different in case of market to market? So we will explain all these values in the next chapter, that is the market structure. So when we will focus on the market structure, then I'll discuss the values of elasticities, right? Okay, third one is income elasticity of demand. As the name is indicating, if there is a proportionate change in income of the consumer, then what will be the change in its demand? So the formula can be represented as proportionate change in quantity demanded of X and divided by proportionate change in income of the consumer, right? And algebraically it can be represented as delta qx upon qx, because we are taking demand in numerator, divided by, in denominator we are taking income, and income is represented by m. So the formula becomes delta m upon m. After rearranging, we have delta qx multiplied by m divided by delta m multiplied by qx. Algebraically, the meaning of these symbols is delta qx is change in quantity demanded of good x, qx is initial quantity demanded of good x, delta m change in income, and m is initial income, means the income before change. Okay, so this is the income elasticity in terms of expenditure, as you know in previous slide. So this is the formula, delta qx multiplied by m upon delta m upon q. So what is the formula for expenditure? Expenditure is always price per unit multiplied by quantity purchased, right? So price multiplied by q. So what we will do to make this formula in terms of expenditure, we have to convert denominator and numerator in terms of expenditure, right? Okay, so let's focus on this part. So what we are doing here, we are multiplying denominator and numerator with price, and delta qx multiplied by b is converting into delta e. E is used for expenditure. Similarly, in denominator, qx multiplied by p is converting into e. So in symbolically, the meaning of these symbols is delta e equal to change in expenditure on a good, initial expenditure on a good, that is E. Delta m equal to change in income, and m equal to initial income. Okay. Okay, let's go to next slide. So when we talk about cross elasticity, we always use angel curve. What is angel curve? Angel curve was given by a German statistician Ernest Angel, and according to him, angel curve states the relationship between quantity demanded of a good and level of consumer's income. So consumer income has been taken on vertical axis and quantity demanded taken on horizontal axis. So in this PPT we have shown angel curve, that is upward sloping straight line. Why it is upward sloping? Because as soon as our income increases, our expenses, or you can say our demand, also increases. So angel curve is upward sloping. So these three positions have been shown here. In the first figure, angel curve is passing through the left hand side portion of point of origin, that is point T. In middle figure it is passing through point of origin, and in the last figure it is passing through the right hand side segment of point of origin, that is again denoted by point T. So with the help of this, what we are doing, with the help of this we are deriving the we can derive the formula of price elasticity of demand. Okay, and according to this formula, suppose I am talking about point S, you need to calculate the elasticity formula at point S. So if I say what is the original quantity demanded, so quantity demanded is always measured from point of origin. So at point S, value of Q is OQ, right? Basically there are four values in our formula: delta Q, delta M, Q and M. So at point S, we have calculated value of Q, original quantity demanded, that is equal to OQ, right? At the same level, the value of income is OM. It means according to formula, value of M is OM. Now the question is, what will be the value of change in money and change in quantity, right? So what will be delta Q? So this is the slope of the line, as we have already understood the slope concept. So in this case at point S, if we calculate the value of slope, then the slope will be you can say intercept on y-axis. So intercept on y-axis, that will be the value of OM, and this intercept of y-axis will represent the change in income, yani ki delta M. Okay, and on horizontal axis this will be the intercept on x-axis with respect to point S, and in this way intercept will be measured from point T to Q. So when we this will be value equal to delta Q. So when we substitute these four values in the formula, the value of OM is cancelled out, and we reduce the formula in this way. Your numerator becomes TQ and denominator becomes OQ, so the value becomes greater than 1. Similarly, same method we adopt in case of second and third figure, and the formula value can be calculated. So in middle figure value is equal to 1, and in the last figure value is less than 1, right? Okay, now the slope of angel curve. Upward sloping in case of normal goods, this can be linear. If we are talking about the necessities, then angel curve can be convex upward sloping, and if we are talking about luxury, it can be concave upward sloping, and sometimes it can be backward bending like this, backward bending in case of inferior goods. Because why it is backward bending? Because in case of inferior goods, we reduce the consumption of inferior goods as our income increases, because we prefer better quality products. So we sacrifice the previously used commodities and replace the better quality products. So the goods that we have rejected after increase in our income, so all these goods are known as inferior goods. So this is the measurement of EC. These are the values that I have already discussed. EPN, proportion of income spent. Okay, if proportion of income spent on good remains the same as income increases, then EI for good is equal to 1, right? Denominator numerator will be the same. If proportion of income spent on good increases as income increases, then EI for the good is greater than 1. This is the case of luxury. If proportion of income spent on good decreases as income increases, then EI for the good is smaller than 1. So this is the case of necessity. So when we take the summation of income, elasticity, budget, considering expenditures, this equation can be given. What is the meaning of KX? KX is the proportion of income spent on good X, and EXI is income elasticity for good X. KY, proportion of income spent on good Y. I am talking about only case of two goods X and Y. Okay, and EYI equal to income elasticity of good Y. When we substitute these four values in this formula, then we will have the total value equal to 1. Okay. Now the use of concept of elasticity of demand in managerial decision making. Price elasticity of demand as a guide for setting prices. So according to sensitivity of the customer in the market, we can set the price of a particular commodity, keeping in mind whether the demand is elastic or inelastic. If demand is inelastic, it means if we are sure that our customer will not change their preference, then we can set the higher price, and otherwise we can set lower price. Cut in prices, keeping in sensitivity with respect to price. Some firms offer price cuts, or you can say discount offers can also be provided to the customers. Income elasticity, growth of sales of products. If the people, if income of the people is going to increase in the market, and the people are more income sensitive. More income sensitive means if income is more, then they will demand more, right? So the sale of the product will increase. During recession, sales will be stable, because during recession generally it has been observed in the market that there is no scope for further income increments, right? So in this case sales will be almost stable. Robust sales during economic development in case of inferior good. So in case of inferior good during economic development, so it will depend on there will be robust sale actually, right, for the planning of the product location expansion as well as advertising and promotion. So this will also affect the demand of the consumer. More and more advertising campaigning will be there, more and more promotion will be there, then more and more scope will be there to change the preference by the customer. So in this case the demand can be more. Number 3, close elasticity, formulation of marketing strategy. It depends on marketing strategy, because this is the case of substitute goods and complementary goods. So you have to keep in your mind whether you are talking about substitute goods or complementary goods. and accordingly you have to take the decisions. It provides information whether or not a substitute exists for the industry's product. If there is no substitute exists in the industry's product, then the manufacturer, or you can say the firm, can increase the price of the product. If more and more substitutes are available, then to set the higher price will be riskier for the firm, because in that case, due to substitute availability, the customer can shift. Next is, this is one more important elasticity that we generally study apart from elasticity of demand, that is advertising elasticity of demand, right? According to this is the ratio of percentage change in sales of a good divided by percentage change in advertisement expenditure. So this elasticity basically indicates if a particular firm is going to change its advertising campaigning or expenses on advertisement, then what will be the impact on the sales of the company. So algebraically it can be represented as delta Q multiplied by A. A is used for advertising here and Q for sales of the good, right, divided by Q multiplied by delta A. So after rearranging, we can have the formula delta Q into A divided by delta A into Q, and the values varies. Whatever elasticity you are going to study, always the values are only the important values, or you can say degrees of elasticities are only 5. That is, infinity means perfectly elastic, greater than 1 relatively more elastic, equal to 1 unitary elastic, less than 1 relatively more inelastic, या आप कह सकते हैं relatively less elastic, and equal to 0 means perfectly inelastic. Factors affecting advertising elasticity of demand: stage of product's market development, the extent to which competitors react to the company's advertising. Obviously, if the people are having any benefit, or if they are changing their perception, they are changing their buying behavior, then definitely you can have an advantage of this advertising elasticity. And then accordingly you can if through advertising demand is going up, then again and again you can also increase your advertising expenses accordingly. Quality and quantity of the company's past and present advertising outlays. So in the past, what kind of outlays you have made regarding advertising, and in current situation what you are doing, this will also affect the perception of the customer, and accordingly they will react. The importance of non-advertising demand determinants. Non-advertising demand determinants means other factors which affect demand except advertising campaigning. Right? Other factors we already studied in case of log demand. Okay. So these factors we are talking about. The time that elapses between advertising outlays and a sales response. If there is a significant difference between advertising outlays and sales response, then the firm will not get more and more benefit. There will be a very much less, you can say, lag between advertising outlays and sales response, so that the firm can have better, the firm can have actually benefits from advertising, because effect will come fast, so that accordingly firm can make further changes in the policy of advertisement. Next is elasticity of factor substitution. This is the elasticity which is focusing on factor, means the production factors. We are taking only two factors of production: capital and labor. So this part will also be covered in the successive chapters, but I am just giving you an idea about it. Suppose we are manufacturing and we are using two factors of production, capital and labor. So in this case, if we need to calculate elasticity of factor substitution. Elasticity factor substitution means what will be the impact of change in price ratio of labor and capital on capital labor ratio, right? So in numerator we are taking price ratio, in denominator we are taking capital labor ratio, means in their quantity ratio. So according to this, the formula, the definition of this is elasticity of factor substitution is the ratio of proportional change in capital labor ratio divided by proportional change in the price ratio of labor and capital. So ratio is represented by K by L. So in numerator value is delta K upon L divided by K by L, and in numerator we we have taken delta PL upon PK, P for price, price of labor, price of capital divided by PL upon PK. After rearranging, we have the formula delta K by L multiplied by PL upon PK and divided by just right, and in denominator we have delta PL upon PK multiplied by K upon L. So after rearranging we have this formula. What is the meaning? Delta K by L is change in capital labor ratio, K by L initial capital labor ratio, delta PL upon PK change in price ratios of factors labor and capital, PL upon PK initial price ratio of factors labor and capital, PL upon PK equal to a marginal rate of technical substitution of labor and capital, that is equal to delta K upon delta L, which is equal to MPL upon MBK. So this last line segment will be clearly explained in the next lecture when we will go to study theory of production. Okay. Next is elasticity of goods substitution. In this case, we are taking two goods simultaneously, X and Y. In numerator, we have taken yes. In numerator, we have taken proportionate change in quantity ratio of X and Y goods divided by proportionate change in the price ratio of X and Y goods. Symbolically, it can be represented as delta Qx upon Qy divided by Qx upon Qy, because we are taking ratio of two goods, divided by price ratio. We have taken delta Px upon Py divided by Px upon Py. After rearranging, we have the formula delta Qx upon Qy multiplied by Px upon Py upon upon delta Px upon Py multiplied by Qx upon Qy. Symbolically, the meaning is delta Qx upon Qy change in the quantity ratios, because we are taking the ratio of quantities. That's why we have used the term quantity ratio of goods X and Y. Qx upon Qy is initial quantity ratio of goods X and Y. Delta P upon Py is change in price ratio of goods X and Y. Px upon Py initial price ratios of goods X and Y. Similarly, here is the price ratio of X upon Py, which is actually equal to marginal rate of substitution of X for Y, that is equal to delta Y upon delta X, which is equal to marginal utility of X divided by marginal utility of Y. So the explanation of this last line I will explain in my successive lectures based on theory of consumer behavior. So I will focus on this relationship in that chapter. This is the diagrammatic representation of elasticity of good substitution. This is the formula. And elasticity of good substitution, this is related with the substitution effect actually. So this part will also be covered in my next lectures that will be based on price effect. Okay, so the concept has been taken from there, so you can have better understanding about this figure after studying that particular chapter. Okay, so for today this much is sufficient, and next time I will start with a new chapter. Till then, goodbye.